Hello, this is Barrett from the C4 Cyber Club at Cypress College. In this video, we are going to cover the Ethical Hacking Lab series, NETLAB 15, Understanding Buffer Overflows. So you may be looking at this and you see a lot of code here. Don't worry, you don't need to know coding for this lab. It's just some copy and pasting or just copying what's in the lab, and we'll go over how to understand what's happening in all these lines, how it relates to buffer overflows. So you may be wondering, what is a buffer overflow? Essentially, it's when a program attempts to put more data in a buffer, in code like this. So you see there's a buffer defined here. So it's a program attempts to put more data into that buffer than it can hold. Or, when a program attempts to put more data in memory past that buffer. So writing outside the bounds of that, it can corrupt data, it can crash the program, but worst case scenario, it could cause execution of malicious code. So oftentimes you'll see an attacker will figure out where that buffer lies and able to execute reverse shellcode, for example, to gain access to a system. So we're going to see how it's important to validate input as a software developer. So we'll go ahead and get started on the lab. We'll be on the Kali machine here. And what we'll do, we'll just go ahead and launch LeafPad. So it's basically like a notepad text editor. And what we'll want to do is copy this code. And this will be kind of good practice to write this all in here. You can ignore the sections in red. Those are technically comments related to the code itself. You're just looking for everything that's in black here. So we can go ahead and get started with that. I am going to jump to the section of the video where I have this complete. Okay, so I have that typed up. If you'd like, you can go ahead and pause this video as well while you get it typed up yourself. So the next step we want to do, we also want to save this file. And we want to do save as. And in the root directory here, we're going to save this as vuln1.c. So this is a script in the C programming language. As you can see here, it details what's happening here. So we're grabbing a value, assigning it to I for an integer value. We're going to add those values into a buffer, and currently the buffer is set to 8 characters. This next section here is us getting the input from the user. We're placing the values into the num variable, and here we're entering the actual values. So I'm sorry, up here we're getting how many integers we want. And then down here, we're actually getting the actual values, and that's going to add that into the buffer. And then down here, finally, we're going to loop through all of that information to display the buffer with all of those values. So, okay, yeah, we got that saved. I'm just going to go ahead and minimize that. And we'll go to terminal. And so since this is a done in C language, we actually have to compile this code because C is a compiled language. Unlike languages like Python or JavaScript, those are what's called interpreted languages, and those work within an environment that runs the code within that environment. So we will just type gcc vuln1.c and then -o for output to vuln1 output compiled file. All right, let's take a look. We'll do a long listing of the directory. And now we see we have this vuln1 program that's highlighted green, which will tell us that this is something we could run. And we will just do ./vuln1. Okay, now you see the script is running and it's asking us for a number of integers. We'll go ahead and type 9, even though we know that the buffer is set to 8. And we can go ahead and enter in 1, 2, 3, 4, 5, 6, 7, 8, 9. And so you could see that we were able to essentially cause a buffer overflow. We went over what the software is intended to do because there was no input validation there. So I have a couple images here that kind of show what's happening. So, imagine this password in blue here is the buffer, but then if you're able to overflow that and input data, this is what could possibly cause crashes or, like I said, most dangerously, remote code execution. And another way to look at it here, here's before the attack. You have various functions that are calling, things in your code. And then if that buffer is overloaded, by an attacker who knows what they're doing and they've determined exactly where the buffer point is, and they're able to inject malicious code, then that will be able to be run on the software side and quite possibly on a server side. So what can we do to fix that? So the last part of the lab here is all about analyzing and modifying this code to prevent this type of buffer overflow. So we'll be doing what's called input validation. And so let's go ahead and pull up our notepad again, or leaf pad. But here's the original code. And essentially, we're just going to be adding a couple things in here. So up top, you want to make sure you add this second include line. And then in this third section here, this third main section, you'll see this if statement. So if num is greater than 8, then it's going to print you entered a value greater than allowed, and it's going to exit the program. So this way, it's not going to allow that particular buffer overflow. So let's go ahead and enter that in right underneath the section where we asked to enter the number of integers. So if num is greater than 8, we will print the line you entered value greater than allowed. And then we will exit the program. In a lot of cases, what you'd actually see is this input validation also within a loop, where actually within the question and the input validation would all be in a loop. So it would ask you again. It would say you entered a value greater than allowed. Please re-enter your number. And it will just keep asking you that until you enter something that's correct. But this is a very simplified example. Okay, so I believe the lab will want us to save this as a new file. So we'll call it fixed vuln1.c. Okay, we're in the root folder here, fixed _vuln1.c. Okay, I'm gonna go ahead and minimize that. And if I do a long listing, we see fixed vuln1.c here. So once again, we'll need to compile this. I'm gonna do gcc fixed vuln1.c, and that output file will be fixed vuln1. If I list the directory again, we see that file has been compiled. Now let's go ahead and test that out, and we'll see if we can overflow the buffer. Okay, so now we see here it's asking us for the number of integers again. Let's go ahead and type in 9. And then there you see you entered a value greater than allowed, and then it exited the program. So that's, like I said, a legit program would be a little bit better, and it would actually, ask you again to make sure that you get the correct input, because otherwise, you have to run this all over again. And then if I set this to 8, you see that it does continue on with the program. So yeah, so that is a pretty simplified example of buffer overflow. There's many different ways to do buffer overflows. As you get more into the topic, you'll find there's things fuzzing. It's just throwing random data at applications to try and determine where that buffer overflow lies, or if there is one at all. And it's through that just randomized input and then monitoring how the program reacts to that allows attackers to find that vulnerability. So this is a very simplified version, but it's a good example of what's happening when you are finally able to locate that buffer overflow. So that concludes this lab, Ethical Hacking Lab series on understanding buffer overflows. Thanks a lot for watching.